Good afternoon, everybody. My name is Sandro Delia. Wow, this light is terrible. My name is Sandro Delia. I'm going to tell you about the next call, ICT01 2018. How is this session organized? We have 45 minutes. For the first 30 minutes, more or less, I will talk and I will try to explain you everything about this. Reminder, never forget to switch down your mobile when you do these things. Okay, this now is done. Then in the last 15 minutes, there will be the possibility to present proposal ideas. There are 4 people who registered on the website. Ideally, if there is somebody who is here with a nice proposal idea and one slide to present it, you can still go on the back of the room to load your presentation on the PC. But in the end, we will have only 15 minutes, so very short presentations, please. Okay. First of all, why we do this stuff? This is the biggest train station of Italy. I'm sure that all of you are aware of this kind of situation where a computer crashes and a lot of bad things happen. This is not very bad because it was just an information system, but if this happens to the system which manages your pacemaker or your robot in the operating theater, then it's a bit worse. So the core activity that we do research on are reliable systems. Let me put everything in context. The European Commission is investing quite strongly since several years and will be even more in the future on what we call the key digital technologies. So the digital technologies which are at the core of every application, because we see artificial intelligence, virtual reality, all the shiny stuff, but at the core, at the bottom, you have a semiconductor, you have software, you have photonics, you have the components of all these things. So if you look at the work program of Horizon 2020, you see that this call is part of the technologies for digitizing European industry. So we are talking about something which is research for an industrial objective, to make industry stronger, to make products, to make something which in the end works. One important thing is that what is done in the work program is complementary to Excel. Excel, there is here you can learn everything about Excel. There is one session downstairs about Excel. Excel is an acronym which means, I think, Electronic Component and Systems for European Leadership, and basically is a joint undertaking. So in jargon it means is an organization where the European Commission puts money, member states puts more money, and the industry collaborates to do research at industrial level, so very much oriented towards the products and the industrial necessity in fields which are similar to this. So I will explain in one moment which is the complementarity between the two areas. Okay, if you are familiar with European programs, you know that these kind of calls are not new, have been done in the past. What is new? There are several novelties. First of all, there were 2 different areas in the past, computing and cyber-physical systems. These have been merged into one. Why? Because we were actually doing computing for cyber-physical systems. So computing this call is not about computing for data center applications and business applications and so on, but for applications where the physical world is affected. The focus of these calls is still the same, so dependable and critical applications at the edge of the network. So again, no data center only, no consumer applications only. But now what has changed is that the most important things are autonomous systems and artificial intelligence. So in all the important cyber-physical systems, you have some kind of intelligence. You have the problem of data management, you have all the kind of problems which come with artificial intelligence. Now, since Excel, as I said, is an organization which finances research and innovation and development for industry-oriented stuff, we changed a little bit the focus, and we want radically new solutions. What does it mean? In the call 2 years ago on computing, we asked for things which were close to the market. Now, if you have an idea which is very close to the market, I say go to Excel. If you want to present a proposal here, we want radically new solutions. That means something which uses things very different from what is in use today, both from the architecture of computers and for the software stack. We know that there are lots of problems nowadays with, you know, the multi-core, the heterogeneous architectures that are difficult to program, that are difficult to use reliably. You don't know, you cannot guarantee the time criticality and all these kind of things. So if you have an idea which improves radically this kind of architecture, and you have an idea to improve radically the kind in which software is developed, because nowadays the software has many different layers, and it's becoming extremely complicated to develop stuff for modern architectures. You know that if you are searching for a job, the unicorn now is the full stack developer. So this means that the companies ideally want people that is able to write a device driver and the user interface of virtual reality applications. This means, I mean, geniuses are not so common in the world. We need different ways of writing software which hide the complexity of the architecture. Lastly, for the systems of systems, for the CPS part, the focus is to support the complete life cycle, because we had a lot of development of good projects on modeling cyber-physical systems. But if you model a cyber-physical system when you set it up, and then the cyber-physical system, the big system like an airport, like a rail network or so on, is used for 50 years, this is not enough. You must have a model that covers the design, the maintenance, the evolution, whatever is done. You know that in software now, one of the buzzwords used is Devops. So imagine that you have to develop Devops for cyber-physical system. Of course, it's completely different, no? Because Devops is based on the fact that in software you do something and you release it in 5 minutes on a huge infrastructure. In a cyber-physical system, you have the physical part, which does not allow this. But the idea is the same. I mean, we need methodologies to manage the complete life cycle of systems. Okay, now we start with the call text. So what you see on this side on the left is the text of the call. Cyber-physical system of systems, like transport networks, manufacturing facilities, interact with and are controlled by a considerable number of distributed and networked computing elements and human users. Okay, this is a definition. These complex and physically entangled system of systems are of crucial importance for the quality of life of the citizens and the European economy. So, this sets the focus. What are we looking at? We are looking at complex systems. We are not looking at simple applications, consumer stuff, small games, and so on. We are aiming at complex systems where there is an interaction with the physical world. This means, in other words, edge computing. So it's not applications which run only in the data center. At system level, the challenge is to bring a step change to the engineering techniques supporting the design, operation continuum of dynamic CPSoS, and to exploit emerging technologies such as augmented reality and artificial intelligence. So we are saying that in the system, the CPS part, cyber-physical systems, or CPSoS, cyber-physical systems of systems, we want to engineering method and tools that support the complete life cycle from when the system is modeled at the beginning to when the system is decommissioned. Things that help in the real usage. So in manufacturing, for example, preventive maintenance, decommissioning, and these kind of things. And of course, we have to take into account the fact that nowadays the user interface and artificial intelligence are an important part of any application. At computing level, the challenge is to develop radically new solutions, overcoming the intrinsic limitation of today's computing system architectures and software design practices. So, the limitations that we have today are, for example, power. If you, the prototypes of self-driving cars use 5 kilowatt typically of computing power to elaborate the information. This is too much. reliability. If you use multi-core chips, guaranteeing the time criticality is always a problem. Complexity, because if you use a complex architecture where you have a CPU, GPU, maybe an FPGA, an accelerator, and so on, programming all these things is something very complex, and debugging it is even worse. So we need new solutions that, I mean, don't cover so much the legacy, but find something radically new that can be good in the development of systems in the future. So, and we cover, by the way, both things. So the architecture of the computer and the way of writing software. And these are two things which go together. You cannot develop a new architecture if you don't develop a compiler or a way to write software for it. The focus is on dependable, physically entangled system for application in industrial sectors. What does it mean? We want serious applications which interact with the physical world. Consumer market is not a priority. Of course, nowadays, consumer and professional applications very often are difficult to distinguish, but I mean, don't come with an application which is only for the consumer because it will be out of scope. For any industry, that means manufacturing, agriculture, health, avionics, whatever you can imagine. But for, you know, applications where there is an economic value, basically. Okay, what else is going on around this stuff? Work is complementary to the initiative on European low-power microprocessor technologies, which addresses technology for HPC application, and to Excel program, which addresses computing for CPSoS at higher technology readiness level. Okay, Excel, I already spoke about it. Excel covers more or less the same stuff, but very close to the market, because industry funds projects which they find useful for their own business. So very close to their business. The European low-power microprocessor technology, there is a thing called an EPCA, European Project of Common, no, Project of Common European Interest, which is for, you find the acronym Euro HPC. What is this? Basically, it's the attempt to build a new microprocessor for high-performance computing applications, which will have two main families, let's say, one for HPC applications and one for automotive applications. Apart from this, there will be, let's say, a collaboration between the European Commission and member states to build the data centers for HPC for the future generation, the so-called exascale data centers. So if you search for Euro HPC, you will find everything. What I mean is this: don't come with a copy of that project, which is already ongoing. There is a project which already started. It's called Mont Blanc 2020. They are developing the first phase of this new microprocessor. Then there will be another call which will follow up, and let's say in a few years we should have the first prototype in silicon of a European microprocessor for HPC, and then in second moment also for automotive application. Be aware of this and don't do an alternative, because there is no need of an alternative. I mean, all the money is already allocated to that one for the development of a new microprocessor, not in this call. Excel, I think, is clear enough. Okay, now the details. First part, we have a part, a research of RIA, research and innovation actions on computing. The title is Computing Software and System Design for Physically Entangled System, Supporting the Creation of Reliable, Robust and Energy-Aware Solutions for Autonomous and Safety-Critical Systems. Again, what are we talking about? Real-time and safety-critical stuff. No consumer application, but many industry application in health, in automotive, and so on. Notice that autonomy and safety are together. This is, I mean, a bad coupling, because in safety, if you go in avionics, for example, you have no autonomy at all nowadays. To have a certification, you must guarantee that your algorithm does A, B, C in a very well-specified time and is completely deterministic. The new applications will have autonomous behavior. Self-driving cars are the most obvious, but imagine in health how many applications we have, in many other fields of industry, manufacturing and so on. we need to guarantee safety even in presence of autonomous behavior. And this is the new, research challenge. This is the core problem of the call. The issue of energy efficiency, testability, trust, cybersecurity should be considered, as well the support of different levels of criticality on the same computing platform where needed. What do we mean? That there are several dimensions to the software of computing applications. Energy efficiency is one. You can do something very beautiful that needs lots of kilowatts. This means that you cannot use in a lot of applications in the edge, at the edge of the network. Or you can do something which works well, but sometimes, like the neural networks nowadays, sometimes just does not work, and you don't know why. So you cannot trust. This, if it is your pacemaker, you don't want this. Cybersecurity, every system nowadays has some kind of communication with the outside, so we need to take into account also cybersecurity in the design. That means, encryption where needed, whatever. So all these things should be considered when you design a solution, as well as, different level of criticalities, because in a car you have the entertainment system where the car manufacturers want to sell the applications and make money, and then you have the braking system that has to work safely and be reliable 100%. So on the same platform you have different things. For CPSoS, we call for models, tools, and methods for design operation continuum of dependable CPSoS, supporting the complete life cycle of cyber-physical systems, from requirement capture to design, test, operation, and decommissioning. So once again, this means covering all the life of the systems. Note that we ask models, tools, and methods. So please don't come only with the theoretical model, will not be enough. We want some engineering tools, some means to really design and develop a cyber-physical system. Projects shall focus on autonomic solutions capable of guaranteeing the overall reliability and security, even when the components of subsystem are not fully reliable and unforeseen conditions emerge in the course of operation. What do we mean here? Please note that is written autonomic, not autonomous. Autonomous is the autonomous car. Autonomic is your heart, which works without you having to think about it. No? So autonomic means that in a factory, we want robots which works alone and which ask for themselves for maintenance that don't require supervision. This means autonomic. And these autonomic solutions need to guarantee reliability and security, even when, of course, like in real life, not all components are 100% reliable. Because in a plane, every now and then, something breaks down. But in most cases, you land safely. Even if there is, a small technical problem, a small technical glitch, the possibility of dying in a plane crash is luckily quite low. This is the objective, that also in the new applications that we see in many other types of industry, when reliability and safety of humans is involved, like in manufacturing, robot for manufacturing, even if something breaks down, reliability and security must be guaranteed. Okay, projects will target TRL 2.5. TRL is the famous technology readiness level, which was invented, I think, by NASA at the time of the space, of the Apollo program. I'm not a fan of TRL, because TRL is good for the Apollo program, but when you work on software, it's quite difficult to define which is the real level. But this is, take it as a qualitative indication to say that we don't want things which tomorrow can become a product. This is not a requirement. We want something which is new. So we understand that the result at the end cannot be something that you sell the next day. But we want a working prototype. Please note that a prototype does not mean, again, a thing with all the bells and whistles of a product that you can sell, but must be something that demonstrates that your idea is not only theoretical, is not only good for scientific publication, but can be really applied. And the working prototype, we would like to have two different use cases. So what does it mean? That you take one use case in avionics and one use case in manufacturing or agriculture, and you try to apply the same technology to different things in any domain. The Commission consider that proposal requesting contribution from the EU between 3 and 5 million will allow this area to be addressed appropriately. Nonetheless, you can submit and select proposal requesting other amounts. What does it mean? That we have 40 million for this call, of which 2 go for the support action, which will be on the next string, or the next slide. The rest is divided between the 2 parts, and we say that in each area we will fund at least 4 proposals. So if you have a very important proposal, very big, you can, I mean, perfectly submit a proposal of 10 million with a lot of partners which lasts 6 years and so on. On the 6th year, I would be very, I mean, unhappy because in this area, I'm not sure that you can do something, you can think today something which will be relevant in 6 years. So I would invite you to not submit very long projects. You can submit projects asking for more money than the 3 to 5 million allowed here, but please consider that this can be, I mean, a limitation in the sense that I tell you very simply, we do the ranking, you know? We, according to the evaluation of the experts, we put the projects in order, 1, 2, 3, 4. So if your project is the 4th one and you ask it for 10 million, then money is out, so it cannot be funded. Only the first 3 will be funded. If you are very good and your project for 10 million is the first one, yes, it will be funded. So again, there is no limitation, but we suggest to consider the range between 3 and 5 million as something which is reasonable. And again, one very important thing, in your proposal, explain which is the area that you address. Even if computing and cyber-physical systems are very close, in theory you could address the 2, please say this proposal is addressing area computing, this proposal is addressing area cyber-physical systems, because at the end, when we will do the ranking, we will select at least 4 proposals for each one of the areas. So if your proposal is on the 2 areas, again, if it is the first one in ranking, will be funded. If it is the 5th one in one ranking and the 3rd one in the other ranking, what do? We cannot fund it. So very practical, please go on for only one of the 2 areas. Support action. The objective of the support action is structured, connect and cross-fertilize the European academic and industrial research and innovation communities in embedded computing and cyber-physical systems. The action should implement technology watch, take up of technologies in real-world use cases, and support know-how transfer. Activities will include constituency building, clustering of related projects, liaison with related programs such as Excel and Eureka, impact analysis, communication of project results, pre-normative activities and road mapping for the future research and innovation. And we will fund only 1 proposal. What do I have to say here? So this is the project which will support the community, which will allow to organize meetings, events, conferences, which will allow to do a roadmap for future research and so on. In the past, there have been 2 different support actions, one for the CSA and one for the computing part. Now there will be only 1, so the 2 communities have to come together because only 1 will be funded. I mean, there is no money for more, basically. That's all. The impact. Okay. We expect the proposal address one or more of these criteria and provide metrics to measure success where appropriate. What does it mean? Measuring the results of a project is not always simple or even possible. So you have to explain why your project, your idea is good and what will be the result. And if there is a metric, if there is something that you can measure, you can reduce the amount of energy for a neural network of 10% of the original. That's very good. If you don't have numbers, please find some qualitative reasons so that during the, let's say, the life of the project, we can see if it is successful or not. For computing, the expected impact is the availability of innovative technologies supporting compute-intensive applications in industrial and professional domains, demonstrating significant and measurable improvement over the state of the art. So we are not prescriptive. We don't say what has to be improved. You can improve energy, you can improve performance, you can improve reliability, whatever, but please explain what you are improving and how you are going to measure it. For cyber-physical system, availability of engineering practices and tools for cyber-physical system resulting in a demonstrable improvement in quality and cost of development and operation for large system of systems. So again, you have to demonstrate what you are improving in terms of the cost of developing the system, which can be normally huge, in terms of quality, because all big systems, when you start them, are not working properly, and in terms of operation. I mean, if you can reduce the number of problems on a railway network of 10% is already a huge economic value. But if you have to identify the metric which is relevant for your project and define it. For the support action, the impact is increased synergies and collaboration between industrial and academic communities. In this area, there is already some good synergy. We want more. We want a lot of collaboration between the industrial and academia, because only in this way what is done can go to the real world. Dissemination of high-quality roadmap for future research and innovation activities in the relevant areas. So again, the job of support action, putting together the community, creating a roadmap and disseminating it and discussing with all the community, and creating innovation activities. Okay, now I have a lot of questions and answers. I don't know if you have questions. Now will be maybe the right moment to do it, but I see a lot of people. So I also encourage you, by the way, to meet me if you need after this. After this session, I will have another one today, but I will be available tomorrow after 1 o'clock for whoever wants to talk to me. So if you need, well, just say hello and we will set up an appointment. Okay, a few important things. Can a proposal address both topics? No, I told already. We will have different, basically, ranking for the two areas, so please specify where is your proposal. TRL 2.5, what does it mean? There is a nice description on somewhere in on the Europa EU website, but you can find it easily on Google. Anyway, consider that this is not, I mean, we are not very formal on this. We simply say, don't come with something which is almost ready and you have to do the last step to go to the product. We need something really innovative. Open source. I am a fan of open source, but if you develop stuff in open source, please be serious. This means not developing stuff and leaving it on a repository for, you know, for nobody to see it anymore, but involving an existing open source community, being active on social media, on whatever it is, having people outside of the project aware of what is happening, and so on. So all the stuff that is doing, you know, that Mozilla or Eclipse are doing, this kind of activities. I'm a fan of open source, but I realize that in many cases, companies want proprietary software. That is fine, that is perfectly fine. But be aware that you have also to explain who owns what. So an important thing, when you develop a new stack of software for the modern computing architectures. And in the consortium, there are 20 partners, very well. Who is the partner that can deploy this, that can sell a product, that can sell consultancy, and so on? Please be clear in your proposal. Should the proposal set measurable and quantified targets for the impact? If possible, if you are good enough to, or lucky enough to find measurable impact, I will be very happy. In many cases, I am aware that it will not be possible to have hard numbers, but at least define qualitative targets. So something that can be, you know, understood. Should the proposal discuss IPR, intellectual property rights? Yes. Not in full details, because the legal stuff is for the lawyers in the consortium agreement. But, I mean, again, be serious. In the proposal, if you are developing something that you believe has a huge value, you should explain who will be the owner, who will be able to exploit it, and what kind of agreement there will be between the partners. Are the proposals limited to 3 years and 5 million? No, again, but please be aware that if you present a very big proposal, you may have trouble, you may not be funded just because the proposal consumed too much money. Can a follow-up to a previous project be submitted? Of course, yes, but it will be evaluated as a new proposal. So you can say, I had project Mickey Mouse 1, and now I'm proposing project Mickey Mouse 2, but we will evaluate Mickey Mouse 2. I mean, it has to be good in itself, not only because there was a previous one. I have an idea only for consumer market. Can I submit? No, only consumer market are not in this call. Do I have well, there are a few things in the evaluation criteria which, I mean, are there and we have to use them. Interdisciplinary approaches, use of stakeholder knowledge, gender dimension in research. Is it needed? Not necessarily. If it happens, for example, if you do something which uses artistic knowledge for training a neural network or something like that, it's very good. But in this field, which is very technical and very specific, is not a requirement. So if you don't have anything, don't try to invent it. This is not a requirement. Do I have to discuss management, risk management, innovation management? Yes, this is a requirement. I mean, the first evaluation criterion is excellence, but then there is also the implementation. And so if you have a very good idea, but then you don't explain who coordinates, what to do when two partners are not in agreement, which are the risks, the technical risks and the management risks, the proposal is not very much credible. So again, I don't want, we have a 70-page proposal limit. We don't want 40 pages of management, but please define which are the important things which are important for your project. Don't just do the copy-paste from a previous project, because normally it's not a good idea. I want to submit a proposal just to see how it works. Good idea? No, it's a very bad idea. The over-subscription rate is very high normally. Please don't submit weak proposals. It's a waste of time for you and for us that have to evaluate 100 proposals. When you have so many proposals, then the result is a lottery, basically, you know? Because you have many good proposals and you cannot fund all of them. So I suggest to newcomers not to go alone, but to get in touch with you know, other partners which maybe have other ideas, which have previous experience and so on. Put ideas together and submit one strong proposal instead of 2 weak proposals, please. UK partners. Okay, this is the formal answer. Brexit is 29 of March, so the 28 when the call closes is still fully, but there is more. I mean, the UK government guaranteed that after the Brexit, they will fund their own partners that participated in Horizon 20 projects. So even if the final agreement will be that UK partners don't get money from Europe, they will get from the UK government. Like it happened, maybe some of you may remember, a few years ago from Switzerland. There was a call when Swiss partners were not getting money from European Commission, but they participated with zero budget and were funded by the Swiss government. Anyway, for the moment, this is not a problem. So the message is, if you have don't kick out UK partners. And I repeat again, don't kick out UK partners. Full stop. It's clear enough. Excel, okay, I already told you about Excel. Again, Excel covers technically more or less the same stuff that we are discussing now. They do every year a call for proposal. Excel projects tends to be industry-driven. So there is academia and research centers, but there are most cases industries is the big driver. And are very, very high TRL because they develop stuff that they want to sell next year. The calls are all published on the Excel website. Have a look because, I mean, if you have an idea that is very close to the market, that may be the best way to go. Okay, that's all from my side, I believe. Yeah, last but not least, we are now searching for making the list of experts for the evaluation. We always look for new experts, so if some of you have a good experience in this area and will not submit a proposal, of course, please send an email to this address. register on the participant portal as an expert. We are looking for experts, especially with industry background and women, because in this field there are not so many women. Okay, that's all from my side. Again, now it's a bit late. There are a few people who are ready to present their proposal ideas, so I invite them on stage. I don't know the order. Maybe you can sit here so that it's simpler. And again, if you have any question, okay, say hello to me now. We can meet tomorrow in the afternoon anytime. So who is the first one? Can you manage this now? Ah, no, okay. Okay, Jack, please stay within the 3 minutes.
This is not the single slide I had. Do you have a, can I put this? No? This is?
You did not give the...
Well, I gave the long one, but then you asked me a short one. I have the short one here.
Okay, so please, let's go to the next one while you load the presentation.
So I need to load the new presentation on the website.
Yeah, okay. Can we load the new presentation on the website and go to the next one, please, in the meantime? Can we show the next presentation? Hello? I have to go with this?
Yes, it's okay, but it's also a longer version. I copied today's PDF with 2 slides.
Okay. I suggest that you come here and go very quickly through the slides.
Okay.
Consider that...
I will try. Okay. Mr. Chairman, ladies and gentlemen, thank you very much for the opportunity to present my research and the research of my university, because I'd like to show my idea, but also to encourage you for cooperation in a new project on ICT call. So first, I'm from Silesian University of Technology. Silesia is a specific region of Poland. It's a very highly industrialized region. So we have a close cooperation. Okay, thank you. We have a very close cooperation with industry. And I'm also a good example of such a cooperation. Starting with my job on my university, I also started my work with industry. The first of my beginning of my career was PLC, programmable logic controller programming. Then I made my PhD thesis focus on supervisory control and data acquisition systems, SCADA. On this SCADA application, I have more than 50 practical installations, and then my habilitation is about manufacturing execution systems. And it's also related with European Union, because we received a funding for Maria Curie Action and Industrial Academy Partnership and Pathways project, and such a project was successfully developed, and I finished it last year. And in this project we have a very interesting task. The task was to prepare a manufacturing execution system for Continental in Ingolstadt. It's not about tires like you can think, but Continental also produced advanced driver assistant systems for other cars, a very advanced technology. And especially in Ingolstadt, they have a production site and also the developing site. And my task was to prepare manufacturing execution system for the prototyping department, because in the case of the mass production, such systems are ready to go and you can buy it. In the case of prototyping, when on your prototyping department you have one day hundreds of projects, each is difficult and different, and it's on the next stage of development. So it's impossible to use something from scratch and something from shelf, and we have to go something from scratch. And it was my idea. Such first project with Continental has been successfully finished, but Continental wants more, and I hope that the idea behind this system is also a good idea to start the discussion about systems of systems, because manufacturing execution system is something which connect all subsystems in manufacturing. So here we have natural systems of systems, and all requirements about which Mr. Chairman spoke about the safety, about the autonomy, about the self-organization of the systems are also true. So my idea is to start such work on the system of system, basing on our existing experiences from the cooperation with industry and also with cooperation with European universities. My faculty, Faculty of Autonomous Control, Electronics and Computer Science, has a cooperation with 90 universities in Europe and about more than 100 industries, not only in Poland, not only in Silesia, because industry is a chain of cooperating companies. So we have connections with many companies in over the world. So I'm very interested in such a project as a partner or maybe as a coordinator, and I open for cooperation. Thank you very much for attention. Mr. Chairman.
Yes, thanks. Okay, next one.
I will go with the long one.
Okay, but quickly, please.
The previous one. So where is it? Can I go back? No. Okay, go. I don't understand how this works.
Hello. Hope it works. Yes. So I represent IACAM, a research center in Paris. So we have a common lab with the CNRS and Sorbonne University, one of the largest research organizations in France. We do research specifically on computer science and signal processing, which will be the topic today. And we apply it to a number of products and collaborations with industry. We are active in EU projects, currently 10 ongoing, some as coordinator. We have also reference for industry transfer, that is both licenses and subcontracting. And so the topic I want to speak today is that we have been developing some specialized computer languages for media systems with human in the loop. And so it has been applied in applications, for instance, for concert, where also there must be some very strong reliability. And the basic idea is that we combine synchronous processes that concern periodic data flow like signals with asynchronous events, so user events, human actions, etc. And with various strategies, I will not come into details, but we do all the process from the formal definition, writing compilers, and also developing schedulers. And also specificities that we develop also high-level visual programming interfaces. So first, a very ancient example is MaxMSP, which is a software which is licensed from us to a company in San Francisco. It has been the main reference for 25 years for multimedia interaction. It's still a leader of that field with several tens of thousands of users. And a more recent application that has been Antescofo, it's another use case. So we have been working with people in real-time languages, like Gérard Berry, who wrote the STRL language for synchronous languages, as part of an INRIA team. And here, the specificity is that we manage frequency variable clocks, because this is the use case. We develop various synchronization strategies. So the idea is that you have a computer that plays together with people, and it's like another performer. The computer listening to what people do in terms of audio, gesture, etc. Then you have artificial intelligence that runs in real time, and so you have a reactive module, and then it plays music with the people. And so the idea, the proposal, is that now we apply these specific approaches of combining synchronous and asynchronous processes in CPS systems. So thank you for your attention.
Just one practical information for whoever wants to speak to me. I will be available tomorrow at 1 o'clock after the session on key digital technologies, which is in the big hall on the second floor, hall A on level 2. So at 1 o'clock the session will end, and I will wait on the left side of the stage for whoever wants to speak to me.
Okay, can we go back to the first presentation? Perhaps? How do I do this? Back is great. Okay, so this is an idea for this call. It's called Self-Star AI for autonomic, trustworthy artificial intelligence. So we want to address this problem. Basically, new techniques of AI, you combine declarative stuff that have been done by engineers specialized in the field, say aeronautics, but they just declare rules, or they draw a base net, and these pieces of declarative knowledge are combined by an inference engine at runtime, sometimes in a non-deterministic way. The engineer does not program the flow of control. And worst of all, those rules or those networks are sometimes learned from data, following a long, complex process of data selection, messaging, pre-processing, and so forth. And in the end, how can you guarantee all the nice properties that are currently guaranteed in critical systems? Okay, so that's the challenge. Also, AI is a very large, confusing, extremely confusing and topic. You have many AI architecture, many reasoning paradigms, for all of them many knowledge representation, many machine learning methods, and how can a poor system engineer or software engineer who doesn't hold 10 PhDs in 10 different AI can choose the right one for critical systems? Okay, and especially non-functional requirements that are very rarely addressed in the AI literature, like time critical or safety, dependability, so forth. And also, we don't really have a nice interoperable component for AI. We're few in machine learning, but beyond machine learning, there's basically nothing that works together. So it's a big integration problem when you do a CPSoS. And this blocks AI adoption for CPSoS. And also it requires, it prevents this kind of systems to be developed by smaller structures, okay? So what we want to propose in this project is to develop a product line using product line engineering approach to AI, to have AI. We focus on explainable AI to be able to certify it to auditors. We propose to use machine learnable probabilistic learning constraint solving rules. So because probabilistic is used for safety. And we can learn those stuff. There's a lot of literature on that. And we propose to compile such rules either in JavaScript for so that it runs anywhere, or if we need the time critical stuff on VHDL and FPGAs. And there are PhD theses written on these topics already that we can leverage. And then we want to use AI for AI. So AI is used to make formal proofs, to apply to formal method, automatic reasoning. So why don't we use some component of this product line to reason on other components or on the assembly of these components with other parts of the CPSoS? Also, we want to be configurable, self-configurable, so we can write meta rules to help the CPSoS system engineer choose among this maze of potential AI techniques to satisfy best their functional and non-functional requirements. Also use some of those components, meta reasoning at runtime, to be able to reconfigure. So you monitor the runtime context, and to achieve autonomy, then you use this AI to reason in real time and to choose another configuration that satisfies the new constraints of the new context that you've just identified. And finally, there is this issue of compliance, which is very challenging, compliance to dependability, cybersecurity, and GDPR. And here, in a sense, you are constructing an argument, like a legal argument, and you have the dependability expert inside the company that designed the CPSoS that tries to convince and present arguments to the auditor of the certification agency that the system is indeed dependable, cyber secure, and so forth. And interestingly, AI has been used to model legal reasoning and to construct automatically, in part, that type of argument. So this is another line of meta-reasoning for more automation, automating the production of the documentation using argumentative reasoning, so that when you go to a certification body, you already have all your argumentation based on either the proofs of critical property or the trace of the process model that you have used to develop your system. So basically, that's it. And I'm Jacques Robin. This is the most important thing. Not this, but the last slide with my name. Yeah. Okay, sorry.
So there is a fourth one, last one. Or, okay. But we are already beyond the time.
So I'll try and be quick. So I'm Alexander Bolter, co-founder of Nucleus VR. So we are basically developing a technology to unite people and their data in real time. So basically we could be the interface between humans and cyber physical systems. Oops. So we have various partners. We've worked a lot in nuclear industry. We're from France. There's a lot of it. So the problem we are addressing is that factories of the futures are very complex systems that generate a massive amount of data. And it's very difficult to get the full picture because all this data is displayed in very specialized software like 3D software, simulation software, there's a letter missing there, IoT, cyber physical systems. So it's all very difficult to get the big picture. And to make this, so this creates inefficiencies and people working in silos, and communication is difficult, made worse by companies working in groups all over the world. So how do we do this? How do we fix it? Well, we base our technology on a digital twin, virtual digital twin, that can be visited by everybody everywhere, and on which you can basically connect all your links to the data, stream data, MES data. We were talking about this earlier. So the idea for this to be actually useful and used, it's actually already used, is to make it very simple, as simple as drag and drop. Basically, you take your 3D data, drop it into our system. It can be CAD or scanned point cloud. And it's automatically prepared to run on all these devices, so VR, AR, just a basic PC. And everything is synchronized together. So what this means is that actually you can do collaborative working together from a distance on a model, cyber physical system, not only in VR, but also you can connect the physical world. So what you can see here is a case where the expert is in Paris, showing somebody how to fix a machine, who is actually the machine is broken down in Mexico. So they interact together. You could say maybe teleportation. So you're actually really in the physical world, and you get all the information by links that are in the digital twin. So if you go on my profile, there's a whole list of videos which show this. Okay, so just one last thing. We recently won innovation contest with ESA for using this system to do remote expertise between teams on Earth and astronauts in the ISS. So we're hoping this will become a reality, but in any case, we should be starting to work with the concurrent design facility of ESA in March. So even though we're just a 4-person startup, it's quite a serious project. So basically, it can be a building block for this call, if anybody is interested. Thank you very much.
Okay, thanks to everybody. So I have to rush to another session now. Again, I will be available tomorrow at 1 o'clock at the end of the session on key digital technology in the big room upstairs. Thank you to everybody.